Up next, we get to hear from JRJ, our head of product here at Dremio, for our product Keynote. Over to you, JRJ.
Thanks, Maeve. Let's start at the start and think for a moment about what makes a lakehouse a lakehouse. The term describes the marriage between open flexibility, unlimited scale, and the promise of the data lake, combined with all the analytical speed, enterprise security, and sophistication of the data warehouse. However, that's really just the start of the story, as the concept has evolved significantly in recent years. The world of open analytics has been transformed by the unbundling of key capabilities, moving them outside the traditional query engine, promoting multi-engine interoperability. A prime example of this is the adoption of table formats like Apache Iceberg, which provide direct, standardized access to data. More recently, we've seen the unbundling of the metadata catalog. This separation is crucial because it allows different tools and engines to work seamlessly with the same data and metadata, developing the concept of interoperability even further. The external catalog acts as the central access point for discovering, securing, and managing the tables it serves. So what is it about Dremio that makes our lakehouse intelligent? Traditional lakehouse approaches often face challenges like performance being compromised, security is less refined, the platform being more complex, or operations being inefficient. Finally, there can be trade-offs between price performance. But Lakehouse built using Dremio addresses these pain points by systematically removing these barriers. Queries are intelligently and autonomously accelerated, and tables are managed and maintained. Access is secure and fine-grained, and the engine is both scalable and affordable. The catalog is open, supporting multi-engine read and write capabilities, as Toma mentioned. In short, it is a lakehouse without compromise. So what makes Dremio a lakehouse platform? We believe a platform is something customers want to build on, integrate it into their broader ecosystem. As a result, Dremio is built as an open, integrated, and extensible platform combining key services, such as our brutally fast Lakehouse query engine, purpose-built for lightning-fast SQL analytics, an enterprise catalog powered by Apache Polaris for modern data management and governance, and our semantic layer, enabling you to discover, govern, and document your data assets, curating data products across your organization. This integrated approach, grounded in open standards like Apache Iceberg, Polaris, and Arrow, is core to our collaborative culture here at Dremio. We understand customers need to unlock value from data for diverse needs, from AI and BI reporting to AI and agentic applications. Crucially, Dremio enables you to build your lakehouse on your terms. This means no vendor lock-in, flexibility in your choice of catalog, all while providing complete control over where your data and your metadata resides and is processed. Dremio empowers you to build your data future on an open foundation. Dremio's power and flexibility are built on a solid foundation of key open source technologies. Let's look at the core projects that make our intelligent lakehouse platform possible. At the storage layer, Parquet remains the dominant open columnar file format for tabular data in data lakes. Providing structure on top of these files is Apache Iceberg, which has become the de facto standard open table format, enabling direct access to this data. Dremio has been a significant contributor to Iceberg over many years, developing deep expertise and sharing extensive resources with the community. One might say Dremio wrote the book on the project. Managing this metadata for these tables is crucial, which is where Apache Polaris comes into the picture. Dremio is proud to be among the original co-creators of Polaris in partnership with Snowflake and others. Polaris provides a standard way to manage Iceberg tables and implement the Iceberg REST catalog specification to ensure open interoperability with the rest of the Iceberg ecosystem. Finally, Dremio's performance DNA comes from Apache Arrow, for which Dremio is also one of the co-creators. Arrow sets the standard for columnar in-memory analytics, enabling high-speed data processing and movement, further enhanced by innovations such as Arrow Flight. This deep commitment to the foundation and leading on open source projects ensures our customers benefit from rapid innovation, avoid vendor lock-in, and maintain flexibility and control over their data stack. How long does it take to create a data set? We all know the answer is often too long. Sometimes it's days, sometimes it's weeks, who knows, perhaps even months. As I mentioned earlier, people often feel the need to compromise on performance or freshness with data lakes as they're bottlenecked in the delivery of data. But another major factor is the process bottleneck. Data consumers, the SMEs in the business, are often blocked by central data teams, the data producers, whom they depend on for timely access or the creation of new views and curated data sets. Dremio helps eliminate this delay. Our platform capabilities, including the intuitive semantic layer combined with autonomous data acceleration, break this dependency. They empower data consumers to self-serve by easily discovering data and creating their own virtual data sets without waiting for central IT and without compromising on performance or freshness. With autonomous performance, we're tackling some of the most common and persistent lakehouse challenges: the need for specialized expertise from central data teams, the time-consuming manual optimizations required to deliver business-ready performance, and the continuous effort of managing acceleration resources. Dremio pioneered query acceleration on the lakehouse with a technology called reflections, which can revolutionize query performance. However, up until now, realizing this potential often required users to manually create candidate workloads, define appropriate reflections, and then continuously create and manage them. This took valuable time and effort away from delivering the actual business value. In this latest release, I'm delighted to announce that we have made reflections truly autonomous. This means the Dremio engine now intelligently analyzes query patterns and data usage to automatically recommend, create, and maintain reflections behind the scenes. It ensures optimal performance with minimal human intervention, significantly reducing the management overhead and democratizing query acceleration for all. Now, automating query acceleration is key, but performance also depends on efficient data layout. So in addition to autonomous reflections, we're also simplifying data management by introducing native support for Apache Iceberg tables. This feature makes it much easier to organize data physically within your tables for better query performance, crucially avoiding the need for users to design and manage complex, brittle partitioning schemes. Together, these advancements in autonomous performance and simplified data management directly address those key lakehouse challenges, reducing reliance on specialized expertise and freeing up your teams to focus on insight, not infrastructure. Let's take a closer look now at how autonomous reflections can achieve this.
Thank you, JRJ. I'm Sharon Kamal, Principal Product Manager at Dremio, and I'm truly excited to show you one of our new exciting feature, autonomous reflections. We've all struggled with slow BI dashboards at some point. Performance tuning can be difficult and time-consuming, and that's why we are proud to roll out this new exciting feature that will delight our customers. For quick definition, autonomous reflections are intelligently created and managed materializations based on query patterns that acts as a persistent cache, automatically optimizing performance while ensuring queries run on a live, up-to-date data with no SQL changes required on the user side. For today's demonstration, I'll be assuming a role of a data analyst working with New York taxi trip dataset. I have 11 BI-style queries that a typical data analyst would run. I will run these queries to establish baseline and then show you how autonomous reflection can accelerate these queries with no performance tuning required. So let's get started. Let's get started by running these queries in Dremio console to establish baseline. As you can see, these queries are taking time to complete. And this is typically what our customers see. Now my queries have finished. Each have taken between 3 to 4 seconds each. And you can see that none of these queries were accelerated. So let's go and inspect the state of reflections from reflections page. I have 3 reflections. They were not leveraged in accelerating my queries because they are on a completely different data set. In version 26, Dremio will analyze query patterns and automatically create reflections. This process typically happens at midnight, but for demonstration purpose, I'm going to trigger this process using REST API. Let's refresh my reflection page to see if there is a new reflection created using autonomous process. Yes, there is a new aggregation reflection. It has a footprint of 1.56 MB and it took 5 seconds to refresh. Now I'm going to go back and run my queries one more time. As you can see, queries are running fast. This dramatic improvement was achieved without any manual intervention. This is power of autonomous reflection. Let me take it a step further and change my first query, which was grouping on hour of a day to month of an year. Yes, the query ran and it took just less than a second to run. So I'm going to go back to the jobs page to see if it was accelerated. And you can see this query was accelerated. What you have just witnessed is autonomous reflections in action. This capability eliminates time-consuming manual performance tuning, delivers sub-second response time for AI/BI workloads, and significantly reduces compute cost. Their teams can now focus on extracting insights rather than optimizing queries, while business users experience consistently fast performance. I hope to see you at our deep dive webinar for autonomous reflections on May 6th. Back to you, JRJ.
Now let's take a moment to look at the performance results using reflections. Running the 1 terabyte TPCS benchmark directly against the lake can take around 7 minutes, which is a pretty good baseline. However, with Dremio leveraging reflections, that time drops to 22 seconds, and that's nothing short of jaw-dropping. It's almost a 20x performance improvement. Now, that's not even the best part. With autonomous reflections, you do not need to spend any time identifying reflection candidates, creating the reflections yourself, managing or maintaining them. The system does it all for you simply by analyzing your query access patterns and then matching inbound queries to the appropriate reflection. What's more, as underlying source tables are updated, Dremio will automatically and incrementally update the reflection, guaranteeing that users only see fresh, consistent data. Now, these benchmarks numbers were produced using the 1 terabyte dataset. What's truly exciting about autonomous reflections is that performance benefit is amplified and magnified as the data volumes and the query complexities rise. What does all this mean? It means your data consumers are empowered. They can serve themselves as Dremio automatically takes care of even the most demanding query access patterns. Next up, let's look at clustering support for Apache Iceberg tables in Dremio. In simple terms, think of clustering as easy mode for optimizing table layout, designed to eliminate many of the headaches data teams face. What's the biggest headache traditionally? Partitioning. Data engineers often have to determine a partitioning scheme without all the information up front. How the table is going to be queried, for example. This guesswork can lead to serious performance problems down the line, like data skew or the infamous small files problem. It doesn't end there. Partitions require continuous oversight and complex management to ensure the scheme remains solid and effective over time. And even after all that effort, optimal partitioning does not always guarantee better query performance. It can be a painful process. So when creating Iceberg tables in Dremio, you have a clear choice for optimizing table layout. The traditional, sometimes complex partition by clause or the modern, simplified cluster by clause. Why is cluster by often the compelling alternative? Well, first, how does it address those painful side effects like the small file problem? By defining cluster by key, you instruct Dremio to optimize the physical data layout during maintenance operations. This process intelligently compacts numerous files into optimally sized larger files, directly tackling the small files issue without needing complex partition schemes just for file sizing. Second, users can achieve more predictable query performance even with highly skewed data. Clustering helps co-locate related data based on the chosen keys, which can mitigate the negative performance impact of data skew more effectively than some partition strategies allow. Finally, cluster by greatly simplifies ongoing table maintenance. Instead of constantly managing and potentially rewriting complex partition structures, Dremio utilizes background optimization processes based on your clustering definition to help maintain an efficient data layout as your table evolves, and that's irrespective of the engine that you're choosing to read or write the data. This significantly reduces the continuous manual oversight needed when compared to traditional partitioning. Choosing cluster by in Dremio offers a powerful and yet simple way to ensure efficient data layout and performance, avoiding many common data lake table headaches. Let's take a look at this in action with a quick demo. Over to you, Casey.
I'm Casey Kars, Director of Product Management at Dremio, and I'm really excited to show you Iceberg clustering today. Iceberg clustering intelligently optimizes the data layout in an Apache Iceberg lakehouse by automatically organizing data files for faster queries, compacting small files, and optimizing metadata to enhance performance and storage efficiency. What makes this so valuable is that it eliminates the manual effort of data layout optimization, dramatically reducing query times and compute costs. For today's demo, I'll be taking the role of a data platform engineer who's supporting analytics teams working with large data sets. A common problem we see customers face is the challenge of optimizing data layout in their data lake. Many data engineers struggle with partitioning decisions that can lead to small file problems and performance issues due to a lack of perfect knowledge of their data up front. Let me show you how Iceberg clustering solves this problem. So if we look here at this table that we created up front, this is a hash partition table from the New York City taxi trips dataset. We're making the choice to partition this by day based on the pickup date time. This would be something that a data engineer or analyst would typically do, thinking, I'm going to filter this data by day, so I may as well partition it by day too, without really understanding the underlying data structure. Once this choice has been made, if we examine the ramifications, by looking at the underlying files of that table, what we see is that there are 730 individual data files, each with about 500,000 records, and approximately 3 megabytes in size. What we've effectively done is created a small file problem for ourselves because we used partitioning to physically separate our data with these rigid boundaries based on date. This is a common customer problem that we see, where customers focus too narrowly on filter criteria of their queries, thereby over-partitioning their data and inadvertently creating a small file problem. The question becomes, how do we make this easier and more intuitive for people creating tables without perfect knowledge of their underlying data, while still getting the performance they want and protecting them from the small file problem? The answer is Iceberg clustering. Looking at the syntax here, we're going to create the same table, the clustered version, and we'll cluster it by pickup date time. Notice we're not doing any transformations on this because we don't have to. It's more intuitive to simply specify the column we want to use. We're working with the same dataset, creating a new table, clustering by pickup date time. So if we look at the files themselves after running this, something interesting happens. Instead of 730 separate files, now we have just 7. And those 7 files are mostly targeting the 256 megabyte file size that Dremio prefers for optimal performance. How does this work from a query optimization and execution standpoint? Not only do we have fewer files now, but because of how a clustering algorithm works, we lay out the data within the files more efficiently. You can see we cluster this table on timestamp. So we have a timestamp lower bound and a timestamp higher bound values for each file. What's notable is that in this particular case, we have non-overlapping segments. This means you will still get the benefits of file elimination during query execution, if you filter on timestamp. However, you don't have to worry about the physical isolation that comes from Iceberg partitioning. You get the best of both worlds. You still get the performance benefits of elimination and logically sorting your data based on your query access pattern, but you don't pay the penalty for making mistakes with your partitioning granularity. That concludes our demonstration of the Iceberg clustering in our latest release. As you've seen, Iceberg clustering eliminates the manual effort of data layout optimization, dramatically reducing query times and compute costs. It helps users make more intuitive choices about data layout without needing perfect knowledge of their data upfront, while protecting them from issues like the small file problem we demonstrated. This is a game changer for anyone building and maintaining an Iceberg lakehouse.
The catalog is the foundation of any lakehouse architecture, but a meta store alone isn't enough to build a true open lakehouse platform. A true enterprise catalog consists of three critical elements: the metadata store, enterprise security and governance, and automated table optimization. To adhere to our commitment to openness and interoperability, we've taken our years of investment in catalog technology and brought that experience to Apache Polaris as original co-creators of the project. I'm joined by Chris Child from Snowflake to discuss how far we've come with Polaris in such a short time and why it's critical for the community that this project is a success. Welcome, Chris. Thank you for joining us.
Thanks, JRJ. I'm excited to be here.
The success that we've seen with Polaris and the momentum that's being built, can you tell me how you've seen that at Snowflake, how your contributions to the platform have impacted the project and helped build the momentum that we're seeing in the market today?
Absolutely. We are incredibly excited by the amount of momentum, the amount of community buy-in, and really just the amount of support that we've seen from the entire community, the entire data community around Polaris. Polaris came out about a year ago, just under a year ago. And in that time, we've seen a number of different partners, obviously including you, buy in pretty deeply to the project, become massive parts of and contributors to the project, and then actually begin shipping it. And I think we'll talk about this a little more later, but actually starting to build it into their own products as well, which we're incredibly excited about.
Yeah, and it is very exciting to see. And it's also important just how the embracing of the open standards and the open nature of being an Apache project, how important that is, not just for the community, but also it's the first step for Snowflake as well into that ecosystem. Is there anything you can add to that about how that journey's been and what excites you about that?
Absolutely. So we at Snowflake, obviously, our focus has always been on how can we help our customers get tremendous value from their data, move faster, make better decisions. And traditionally, we had to do that by building our own proprietary format and our own proprietary catalog. And what we're really excited about and what we've seen over the last few years with Iceberg and now with Polaris is that we can actually provide the same experiences, the same ease of use, the same performance, the same governance, a lot of the things that you mentioned earlier, on top of open formats, which really allows customers to get more value out of their data and use it in a more open way. What Polaris really brings to that, though, is just having your data in an open format in a place that people can access, it's not enough. You need a catalog, and you need, ideally, a catalog that's truly open source, that's community supported, that is supported by not just the community, but also by multiple vendors and many different vendors. I think it's very important that you have the catalog, which governs access and controls exactly how you use the data, that's open, that's community supported, and that's truly an open standard as well. And that's why we've been so excited about Polaris and why we've been so excited to work with Dremio on this.
Oh, that's great. And I think also just building on that, one of the things that we've seen as well is that the shift towards the Iceberg REST catalog specification has enabled a kind of technology neutral implementation that has meant, I certainly saw it for ourselves, in support of, say, AWS S3 tables or Confluence Tableflow, how quickly and easily we were able to seamlessly interoperate and integrate into those ecosystems and support those launches as well, which has been fantastic for us and also for our partners in the ecosystem. I know Snowflake also played an important part in those launches.
And we're seeing it even beyond that. I say it's a little bit of, this is sort of taking us towards the place that we've been trying to go as a data industry for a long time, which is how can we actually interoperate and have the same piece of data exist once, have different vendors, different pieces of software, different tools, all able to use that together in kind of a single, coherent, well-governed way. And it's the combination, really, as you said, of not just Iceberg, but the Iceberg REST catalog, and then an open implementation like Polaris. That's what's really started to open this up. And we're seeing now, not just our customers adopt this, but a lot of the other vendors that we work with are opening up their data in an Iceberg format behind catalogs like Polaris in a way that really allows suddenly that data to be activated and used without having to move, without having to be transformed. There's kind of a ton of savings and a ton of complexity that we're able to reduce for the whole ecosystem.
Yeah, 100%. And I think that is enabling us and our customers to build stronger data architectures as well, and embrace and enhance the ecosystem that they have that is their reality.
Absolutely.
Right, which is great, because there is so much data out there. Yeah. And just being able to provide direct access to that data provides customers with that flexibility and choice. That seems to be so important in this ecosystem and the true spirit of open interoperability. In closing, is there anything here that you would also like to think about, or how you're thinking about the community and the contributions that Snowflake would like to be able to see happening in that space as well?
I think it comes back to what we were talking about before. More community contributions is better. So I think we are always looking for partners, companies, vendors, individuals, anyone who wants to contribute, we're looking for. And you mentioned this, one of our aspirations is really to graduate this to a top level Apache project. We want to make this really the standard way. We think that anyone who's building a data lake on top of Iceberg catalogs and manages that data, that's the aspiration here. And so we are excited to continue contributing heavily to the project. But again, it's important. I think it's actually very important to come back to something we said at the beginning, which is if this is primarily driven by a small number of vendors, it's not going to be successful in the aspirations that we've both set out for it. We want this to really be a community-owned, community-driven, community-led project. And so for that, we need even more people from the community to be part of it and to be contributing.
Yeah, that's great. That's great. Thank you very much for taking the time to join us today, Chris. It's been great to have you on.
Oh, thank you very much. And I'm excited to continue working together on this.
Great. Thank you. In June last year, we launched the incredibly successful definitive guide for Apache Iceberg. Building on that success, I am delighted to announce today that Dremio's own Alex Merced, Andrew Madsen, and our founder, Thomas Charan, are co-authoring Apache Polaris, the definitive guide. This book will be the go-to resource for understanding and leveraging Apache Polaris effectively. Since relaunching Dremio University last November, we've seen tremendous demand for lakehouse education. We've already released over a dozen courses, awarded over 800 badges, and attracted thousands of users to our educational platform. You can take advantage of this totally free resource as well. For deeper knowledge on Apache Polaris, check out our course, Apache Polaris, the metadata catalog for Apache Iceberg. A key component for delivering an intelligent lakehouse is its semantic layer. At its core, this layer provides a unified, business-friendly view of your data, standardizing definitions, documenting purpose, identifying metrics, and visualizing lineage and relationships across the organization. One crucial role it plays is enabling intelligent data discovery. As Toma discussed, AI agents often need to find data, but their prompts aren't always precise. The semantic layer provides the necessary bridge to interpret intent between exact keywords, connecting them to the right information. And semantic search isn't just for agents. People need that bridge too. This is especially true in the modern workplace, where the colleague sitting next to you for quick questions might now be a Zoom call away. Finding the right data efficiently becomes even more critical in the modern workplace. This is why we've built these powerful semantic search capabilities directly into the Dremio platform, making data discovery intuitive for everyone.
Thanks, JRJ. I'm Isha Sharma, Director of Product Management at Dremio, and I am thrilled to demonstrate AI-enabled semantic search, one of Dremio's newest capabilities as part of this next generation release. AI-enabled semantic search makes it simple for users to discover data assets and more in their enterprise's data estate, just using plain business language. No SQL or technical expertise are required. So today, I'll step into the role of a data analyst at a large organization who is looking to quickly find relevant data sets for an analytics project. Let me show you how this works. For this demonstration, assume that I have limited knowledge about the data sets that are in this environment. So to access search, you can click on to the search bar on the top left or use keyboard shortcuts like Command K. So let's go ahead and start by searching for NYC. And as you can see, search immediately returns direct matches based on table names alone. Also notice that the results are case insensitive, which means you don't have to exactly match the object name or the capitalization. You're also getting back jobs, and those are based on queries that have run on the relevant data sets. And so if you wanted to filter these results down by tables only or jobs only, you could do that. Now, next I'll show you a semantic match. So if we type in rain here, you'll see that you get weather-related data sets. Rain is not in the object name or in the object description, but our semantic search understands the relationship between rain and weather. Next, moving on to scripts, you can of course search by the script name, but more importantly, if you don't remember the name, you can search by the content of the script or objects that have been referenced from within the script, which is super valuable when you're working across numerous scripts in an organization. Now, coming back to tables, I'll show you how you can leverage metadata in your search. Many organizations use labels to categorize and classify their data sets. When I type in public data, which is a label in our environment, you get back NYC taxi trips iceberg, as it's classified that way. You can also search for content that appears in wiki descriptions. So for example, searching for TLC will give back matches where the acronym has been used in the documentation, not just the table names. Finally, our advanced search allows you to filter results by advanced parameters such as owner or last updated time. And when you found a result that is relevant, that you'd like to explore more or query more, you can go straight to our SQL runner and query it immediately, creating a seamless flow between discovery and analysis. As you've seen in this demonstration, AI-enabled semantic search reduces data discovery, the time from days to seconds, even with complex data environments. Faster data discovery significantly accelerates AI and analytics initiatives. I hope to see you on May 27th at our deep dive webinar on data discovery with AI-enabled semantic search. Back to you, JRJ.
Okay, let's shift gears and talk about integrating the rapidly evolving world of AI agents with your enterprise data in Dremio. A major challenge holding this back has been the lack of standardization. Historically, every AI agent and every tool required complex custom integrations just to communicate effectively. This is where MCP, a new open protocol backed by industry leaders such as Anthropic, OpenAI, Microsoft, and now Dremio, is changing the game. MCP standardizes how AI agents discover, understand, and invoke external tools and data systems like Dremio. Think of it as creating a universal translator and interaction standard for AI agents.
Hello everyone, I'm Aniket Kulkarni, software architect at Dremio, and today I'm excited to talk about Dremio's new MCP server. I want to use some real-world use cases to showcase how powerful it can be. So for that, let me tee things up. On a recent project, I wanted to come up with default resource recommendations for memory and other things for various Dremio components to put in our help chart. I would usually use the anonymized and sanitized product telemetry that we gather to our internal data lake. And for that, I would just go to my friend AJ, the product manager, who owns these data sets, who is familiar with the layout and the relationships of data. But he is unfortunately out. So then the other option I have is to use the Dremio semantic layer, go to the data sets myself, explore these data sets, and find out all the answers that I need to find out. But how about I show you another way to do the same without knowing anything about the data? And this involves using the Dremio MCP server. So here I have started up Claude Desktop, which is integrated and configured to use the Dremio MCP server. If you want to know more about how to configure and how to connect Dremio MCP server to your Dremio instances, we have a blog up on dremio.com. So with this, let me start by something simple. Let's just ask it to list all the tables that contain any metrics that I might have collected for customers clusters. And off it goes. It will obviously, the server will ask us permissions to make sure that we are okay using the tools that it has discovered from the Dremio MCP server. And then with that, it will start exploring for us and do some cross-referencing and try to come up with insights that will hopefully allow us to figure out the answer that we need, or if we want to get a overall breadth of information and then dive deeper into things that are of interest. So let's just let it do its work for a little while, since it's searching through all the data that we have gathered. As we can see over here, it is already starting to zero in on some of the tables that it feels are relevant. Looks like it is already starting to list out some of the things, and just eyeballing this, I can see that the schema, the space called support, seems to be interesting because it has a few of these things that seem to relate to sanitized data from the customers. Let's see if we can. So let's actually ask it to dive in and zoom in more on the support space, and within that schema, if it can find more information. The exploration seems to be going well because it seems to have narrowed in on some tables, which by the look of it seem to have to do with memory and other resource related things, as evidenced by things like max heap cluster, and that's what even Claude says. Now, it has also done some sampling, so I'm able to figure out that both the infrastructure metrics table has Kubernetes versus non-Kubernetes deployments, and just beyond the names of the tables, it has given me something more to work on. So it is also suggesting that I can build on top of this for ease of future analysis by creating views, by creating data products. We'll take it up for that suggestion as well. So first, let me try to get to one of the core questions I had. If I'm interested in the overall spread of memory usage for various components, can it actually help me do that? Now that it seems to have finished analyzing, it's also helping me out with a at-a-glance visualization so that I can quickly consume the data that it has created. This gives me quite a great spread to look at how the spread of memory allocation per coordinator versus executor happens across releases as well as across organizations. This is great. I can consume this data. But now that even Claude itself suggested that it can help me create views for future analysis so that I don't have to go through all of this again with it. Let's actually take it up for its word. It also looks like it figured out an issue when it was creating the memory usage, the original memory usage visualization. Looks like it is trying to correct it. So we'll give it some time to correct itself, and then we will ask it for its next thing, which is can it create a view so that next time I can just consume it directly from Dremio's semantic layer. Right? Looks like it has created 6 views for me, or more like 10 views for me, and everything based on customized settings to normalized usage and usage by organization, as well as other details. I can now just copy this and try to create all the views that it has recommended, and off we go. And this is great. Now, going forward, I can just use this, and it can also help other folks who come down this way. So to recap, I came into this having a problem statement of trying to understand the overall spread of data and trying to understand the overall use of various settings and various cluster metrics, not knowing anything about. And so there we go. I came into this not knowing anything about the overall data layout, and just using MCP server and chatting with my LLM, I could actually explore everything that I have collected, all my data, actually generate insights, solve my problem, get an answer to my question, and also make sure that any further questions down this are easily answered by having reusable data products created at the end of my analysis, just in the last few minutes. Thank you.
Building on our core commitment to openness and interoperability, we're excited to introduce the Dremio MCP server. This is our new open source project that acts as the bridge, allowing any AI agent fluent in the MCP protocol to seamlessly and insecurely interact with your Dremio intelligent lakehouse platform. What does this unlock? Through the Dremio MCP server, agents can now leverage Dremio's capabilities to discover relevant datasets, views, and critical metadata guided by Dremio's semantic layer context, intelligently translate natural language questions into executable SQL queries, and directly run those queries against your governed lakehouse data. You can even perform semantic searches to find the most relevant data assets for the task at hand. The benefit here is significant. You can eliminate the need for complex one-off integrations for each AI agent or model. This allows you to more easily build natural language interfaces to your data, enable powerful automated workflows driven by AI agents, and securely connect these agents to the trusted, high-quality, governed data within Dremio. The Dremio MCP server is a key step in making the vision of AI agents interacting fluently and securely with enterprise data a practical reality on the lakehouse. So as we bring this session together, the architecture you see visualized here, the semantic layer, the accelerated query engine, and the enterprise catalog represent the core of Dremio's intelligent lakehouse platform. Throughout our discussion, we've seen how these integrated components work together, built upon a fundamentally open foundation, leveraging standard formats such as Apache Arrow and Apache Iceberg to ensure flexibility and avoid vendor lock-in. At the heart, our enterprise catalog, powered by Apache Polaris. It's about delivering performance and ease of use, openness and strong governance, self-service and efficiency. This is the lakehouse without compromise. Ultimately, Dremio's intelligent lakehouse platform is designed to empower your organization, accelerating data discovery and analysis, and freeing your teams to innovate faster using all of your data. So we've explored the capabilities of Dremio's intelligent lakehouse platform, but bringing that power into your organization also means having deployment flexibility. We firmly believe Dremio should be available on your terms, fitting into your infrastructure strategy. As you can see here, Dremio provides options across all the different environments and management models. Whether your data resides primarily in the cloud or on premises, we have you covered. And whether you prefer to manage the Dremio software yourself for maximum control or leverage a fully managed Dremio SaaS offering, you have that choice. We provide complete Dremio platform offerings for self-service managed deployments, both on-premises and in the cloud, as well as our fully managed Dremio cloud service. Once you've got to grips with the spring release, I'd strongly recommend exploring our open source MCP server and build the future of agentic apps. You'll be amazed at what you can achieve with these products. As you can probably tell, we're incredibly proud of this release and confident it will help you unlock more value with less effort using our intelligent lakehouse platform. We hope to see you in the upcoming sessions, and we look forward to hearing about your experience. Come build the future with us. Thank you.